Hello, this is Mr. Win, and today's video will be on Lesson 5-1, Operations with Polynomials. So, make sure you know how to multiply and divide monomials. So, to simplify an expression containing powers means to rewrite the expression without parentheses or negative exponents. Remember, monomial is a single thing, not being abstracted, but they can multiply as many things as they want. Make sure you know your rules of exponents, properties of exponents. They are in the formula chart. But you have two things that are being multiplied at the same base. For example, 3 squared and 3 to the 4th. So that's the bases are 3. You just add the exponent. So 2 plus 4 is 6. So that's 3 to the 6th power. A lot of students will get this wrong. They'll say that's 9 to the 6th power, but that's wrong. The bases don't multiply, just the exponents add. Quotient powers, if you're dividing two things with the same base, you just subtract the exponents. So 9 to the 5th divided by 9 squared is really just 9 cubed. Because 5 minus 2 is 3. Negative exponents, we can't have that. We have to switch that over the fraction. So what they did here is they divided this by 1 and they flipped it. So they put 1 on top and a, or x to the a power on the bottom. Power over power, you have a single thing, a monomial, and that's raised to another exponent. You can just distribute the power in. So for example here, they have 3 cubed. Raise that squared, we'll just multiply the exponents inside by 2. So 3 times 2 is 6, 3 to the 6th power. Power of a product, same thing. It's still a monomial. You just distribute the exponent to everything inside. Power of a quotient, same thing. You distribute everything inside because that is still a monomial. Just distribute everything to inside. And anything to 0 power is 1, as long as x is 0. So 7 to the 0 power is 1. Make sure you know when something's fully simplified. No powers of powers. Each base shows up once. No reduced fractions and no negative exponents. So here's some examples. We might use different properties, but this first one, there's no exponents outside the parentheses. So I'm not distributing them. There's not power to the power. Technically, the parentheses don't even matter. So I'm going to rearrange it. I'll put all the numbers in front and all the letters together. So this is the same thing as 2 times 3, there's no more numbers, times a to the negative 3rd power, or sorry, negative squared power, times a cubed, b squared, and c negative 2. Well, we just do simplifying. 2 times 3 is 6. A to the negative 2nd times a cubed, they're the same base, I just add them. Negative 2 plus 3 is 1, so a to the 1st power, b squared something to do, and c to the negative 2. Well, I'll see over here. Alright, so I multiply everything. Now I'm going to take care of all my negative exponents. Since c to negative 2 is on top of a fraction, I need to make this a fraction and move it to the bottom, move to the other side. So c squared goes down here, and that's my answer. So everything with the negative exponent moves to the other side of a fraction. If it's on the bottom of a fraction, meaning the denominator, it moves to the numerator. If it's already on top of the numerator, it moves to the denominator. Alright, oops, I'll leave it there. I'll move it up here. Alright, number 2. We have division. We have division of q's and r's. Well, when we're dividing same bases, we just subtract the exponents. So q squared divided by q7, that's really q2 minus 7, that's q to the negative 5. Then r4 divided by r3, well, I subtract them. 4 minus 3 is 1, so that's r to the 1st. Well, I see that negative exponent with the q, I move that down. So that turns into r to the 1st power. You could write it if you want, it's invisible, over q to the 5th. In this last one, we have a monomial. An exponent outside, power to power. Distribute this exponent to everything inside, including that negative. So this turns into negative 1 cubed times 2 cubed times a to the 4th cubed over b squared cubed. Well, just fix that. Negative 1 cubed is still negative 1. 2 cubed is positive 8. A to the 4th cubed is really a to the 12th. I just multiply those numbers. And b squared cubed is b to the 6th power. and I will fix that front part. Negative 1 times 8 is negative 8. Negative 8a squared over b to the 6. All right. Simplify and find the degree. This is old. Do you know how to combine like terms? Make sure you know when to multiply and when to add or subtract. Well, this is a subtraction problem. So do the parentheses matter? The first one does not. So I just drop them. The second parentheses does matter because there's a negative sign or a number in front. I must distribute a negative 1 to everything inside. So that is negative 2x squared minus 3x plus 1. Combine like terms. Well, for x squareds, I have that. So 4x squared minus 2x squared is 2x squared. For the single x's, negative 5x minus 3x is negative 8x. Positive 6 plus 1 is positive 7. I simplified it. Now degree. Degree just means what is the highest exponent of the monomial. So we see three monomials. We have this one, and this one. The degree is the exponent. So the degree of the first term, 2x squared, is 2 because the exponent on x is squared. X squared is 2. This degree is 1, this degree is 0. When they actually do this from the highest number, so this degree is 2. Degree equals 2. Right, so y'all know how to combine terms. Now we're just adding degree. What is the highest exponent you see? All right, same thing here. This is a multiplication problem. We're going to distribute everything. It's kind of like FOIL, but it's really 3 things. So I'm going to distribute this to both of these. So n squared times n is n cubed. N squared times 2 is positive 2n squared. As next term, positive 4n times both of these. So 4n times n is 4n squared. 4n times 2 is 8n. And that last one, I'll use black. So this times both of these. You go on below, above, doesn't matter. That's minus 6n minus 12. Combine like terms. So n cubed combines with nothing, so that's taken care of. Both of these have n squared. That makes positive 6n squared. This has just n, so that is plus 2n. And that 12 has no one combined with. That's by itself. Right, there's my simplified answer. Now the degree, the highest exponent I see is 3. So my degree is 3. Last example, same thing. To simplify, find the degree. Well, this is just a distribution problem. So I'm going to distribute this to all 3. Now this combines with those exponent properties earlier. So n squared x times 4n, well, number times number, letter times letter. So n squared times n is n cubed, and x is just x, and multiply with that. Next one, 5, n squared times n squared is n to the 4th power. X times x to the 5th is x to the 6th. You add the exponents. And the last one, minus 2 n squared x. All right, that is the simplified answer. Now the degree. So all these are monomials. I have not told y'all, when there are multiple letters, you want to add their exponents together to find the degree. So for this monomial, you see the exponent 3 for n, the exponent 1 for x. So 3 plus 1 is 4. That's the degree of that. For this middle term, n has 4, x is 6, 4 plus 6 is 10. That degree is 10. And this last one, n has squared, x is first, 2 plus 1 is 3. So my degree here is actually 10. That's our degree. All right, I'll end with this practice problem. Simplify it. You should get that answer. Also tell me the degree. So the degree should be 3. All right, if you can do that, you should be fine in class. Again, this is Mr. Wynn. Thanks for watching. See you in class.